The first thing to observe about this equation, logarithmic equation, is that any solution x, any value of x that would be a solution to this has to be greater than 0. And that's, if you think of the domain of the entire equation, x has to be greater than 0 to be in the domain of just the ln term all by itself, notwithstanding any of the rest of this stuff. And recall what the graph of any logarithm function looks like with a positive base. Looks something like this. It passes through 0.10, right? Because any base raised to the 0 is equal to 1. Okay, so that's a graph of just stereotypical natural log function. That point right there is 1, 0, 1, 0. And just from the graph alone, we know the logarithm function has a non-negative or a positive domain. Okay. And notice just right across the axis would be the exponential function. Okay, right across the line y equals x, you would have the exponential function. So we see this is the inverse of the exponential function also. Now this problem isn't particularly difficult. I'm just doing it because it came out of an old textbook where they didn't really test the solutions like I thought they should have at the end of the problem. Now, so we're just going to use some of the well-known properties of logarithms right here. Notice that ln x plus ln of this object is just ln of the product of x in this input argument. And of course, that's the result that says natural log, or any logarithm, natural log a plus natural log b. And I'm just in the name of time, I'm not using the parentheses like I prefer, since the logarithm is a function. Now here to me, the parentheses are a little more, shall we say, necessary. But this says the sum of two logarithms ends up being related to the product of inside the single logarithm. Okay, the log of two inputs. Well, you know what I mean. This is the log of the sum is equal to the log of the product, I guess is the way you wrap that in English. And that's exactly what happened going from here to here. Okay, these two terms. This would be like your ln A, this would be like your ln B. You juxtapose the A and the B and you get this, okay? Now the very next one is a similar property that says ln of A over B. And this just has to do with properties of exponents. You subtract exponents when you have quotients, right? Okay, that's equal to ln A minus ln B. Okay, and that's what leads to this statement right here. We have a difference, okay? We have a difference of two logarithms. This minus sign that you see right here is the same as the minus sign you see right here. And so this pair of logarithms becomes a single logarithm, okay? Now the very next line is just based on the fact that ln of anything, well, let's just use question mark, ln of question mark. It really means log base e. Okay, log base e of that, and let's put it in parentheses just for grins. Okay, like that. Okay, and so they're inverse functions. So this statement right here and this statement right here are equivalent. These two statements indicate the two functions are just inverses of each other. I did e to the 1 for emphasis because I exponentiated this side. E to the ln of something is the something. Okay. Now, if you carry on right here and do all the algebra, once we've gotten rid of the transcendent nature of this thing, you end up with this fairly easy to factor object, okay? And so very clearly we see the two possible solutions would be, we can do solution set notation if you want. 2e is clearly a solution. Okay, now this is the possible solution set. And of course, if you set this linear factor equal to 0, you get x is equal to minus 2/3, right? Now notice we would have to reject this guy right here because remember at the very beginning, we based on just the domain characteristics of the logarithm function, the input has to be greater than 0, and this would even impose more of a on it, but we know that the input has to be greater than 0 just from this term alone, okay? And so we have to reject the minus 2/3, All right, so we'll mark this out. How do we want to do that? Just X that out. Okay, that one doesn't count. So the only solution would be, it's called extraneous, I guess, in some contexts. Okay, and so you get X is equal to 2E as the only solution. Now, in the textbook of this excellent textbook, like back in 1969, they didn't do this. They just said the answer is 2E. They didn't make any note at the beginning of the problem that any solution to this would have to be greater than 0. And I think that's a great practice. Before you even get into the mechanics of solving it, write down the domain of the equation, and then you can compare that to whatever solutions you happen to get when you actually do the math. But in any event, this is the final answer, and thank you for viewing.